We are going to start now the chapter 2 of class 10th mathematics. It is polynomials. We have divided this chapter in two lectures. So we start this chapter with some basic definitions related to polynomials. So an expression of the form px is equal to, this definition is given over here, this px is equal to a0 plus a1x plus a2x square plus so on up to an x raised to the power n, where an is not equal to 0 is called a polynomial in x of degree n. So this definition we have already studied in our previous class, in class 9th, and these a0, a1, a2, an, these are the real numbers. We are saying these are called the coefficients, and n is called the degree of the polynomial if an is not equal to 0, and this x, it is, we are saying it is the variable over here. So some polynomials are given over here, some examples are given over here, that 3x plus 5, this is a polynomial of degree 1. Degree 1 means this, the highest power of x, it is 1. Similarly, this 8x square minus 5x plus 3 is a polynomial of degree 2. Next, this polynomial is given to you 2y cube plus 4 by 9y square minus 3y plus root 3. This square root 3 is there, and this square root 3 is a real number, so it is not creating any problem. So this is a polynomial of degree 3. Similarly, this next polynomial that is given to us, it is 3z raised to power 4 minus 5z cube plus 2z square minus 8z plus 1. This is a polynomial of degree 4. So these are some examples of the polynomials. Next, we are talking about, if this expression is given to us, we are talking about this expression, it is square root of x plus 3. So it means it is x raised to power 1 by 2 plus 3. So this power over here, we are saying degree n should be a non-negative integer, but over here this is not a non-negative integer, so we are saying this is not a polynomial. Similarly, if I am writing 1 over x plus 5, then this is just like this power of x that we will have. If we solve this, this will be negative power of x will be there, or we are saying it is x plus 5 raised to the power minus 1. Again, it is not of this form, so it is not a polynomial. Similar is for the next case, that it is 6 over x square minus 3x plus 1. This is also not a polynomial. So one thing that is to be noted over here is that if I am writing x plus square root 3 and when I am writing square root x plus 3, in this case, in this first case, we are saying the highest power of x, it is 1. This root 3 is a real number, this is allowed. The power of x that we have, it is a non-negative integer, so this is a polynomial. But when I am talking about square root x plus 3, this is not a polynomial, because power of x is 1 by 2. So power of x should be a non-negative integer. Next are some terms related to polynomial. So linear polynomial means a polynomial whose degree is 1. It is called linear polynomial. So these are some examples given over here. So details of all these are available in our video related to the polynomials that we have studied in class 9. Next is the definition of quadratic polynomial. Quadratic polynomial means whose degree is 2. So these are the examples of some quadratic polynomials. In all these polynomials, we have the highest power of x that we have, it is 2. Next is cubic polynomial. Cubic polynomial means whose highest power is the polynomial of degree 3. The highest power of x, or the variable we are talking about, it should be 3. So the general form is given over here, that px is equal to ax cube plus bx square plus a cx plus d, where a is not equal to 0. This is called a cubic polynomial. So examples are given over here. These all are the examples of the cubic polynomials. These are the examples of cubic polynomials. In all these cases, the highest power of the variable that we have, in this we have variable x, over here second case we have variable y, in third we have variable z, and the highest power of the variables in all these three cases, it is 3. So these are the cubic polynomials. Next is biquadratic polynomial. A polynomial of degree 4 is called a biquadratic polynomial. So biquadratic means we are talking about the degree over here now. The highest degree that of the variable, it is 4, or highest power of the variable is 4. So degree of the polynomial is 4. So we are saying the general form of a biquadratic polynomial, it is a x raised to the power 4 plus bx cube plus cx square plus dx plus e, where this a should not be equal to 0. This should not be equal to 0. Then this x raised to the power 4 will be there. This x raised to the power 4 will be there, and this will be the degree of the given polynomial. 4 will be the degree of given polynomial, and it is called a biquadratic polynomial. So these are some of the examples. This is one polynomial that is given to us. This is second polynomial that is given to us. So these are the examples of the biquadratic polynomials. Next is value of a polynomial at a given point. So we are saying if px is a polynomial in x and alpha is any real number, then the value obtained by putting x is equal to alpha in px is called the value of the polynomial at x is equal to alpha. So this thing is explained with an example over here, that if polynomial px is given and it is, this polynomial is 2x square minus 3x plus 5. This is the polynomial that is given to us. Then we are saying what is the value of this, is the polynomial px. What this x means, that the variable over here it is x. So if we have to calculate the value of p of 2, it means we have to replace the x, this x square, in this x we have to replace this x with 2. So our answer will become 2 into 2 square minus 3 into 2 plus 5. Whatever value is given to us, we will replace that value. When you solve this, you will get the answer is 7. Similarly, if I have to calculate p of minus 1, it means what we are going to do, 2 is already there. This polynomial we are talking about is 2 is already there. Next thing that we have to do is we have to replace it with x with minus 1 square. Next it is minus 3 is already there. Next in place of x it is minus 1, and then it is plus 5 is there. So when you will solve this, you will get the answer is 10. So this is called the value of the polynomial px at x is equal to minus 1. This is the value of the polynomial px at x is equal to minus 1. So it is 10. This is p of minus 1. We write it like p of minus 1 and its value is 10. Next is zeros of a polynomial. So we are saying a real number alpha is called a zero of the polynomial px if p of alpha is equal to 0. We are saying some polynomial px is given to us. We want to find some real number alpha. This we want to find, or we are saying this number is there and this is a real number. What is the property of this number? That if we find the value of the polynomial at this point alpha, then the answer is 0. Then this alpha is called the zero of the polynomial. So if we look at this example over here, we are saying that px is equal to this. This is the polynomial given to us, and we have to find the value of p of 3 and p of minus 1. So when we calculate the value of p of 3, So it is 3 square minus 2 into 3 minus 3. The answer that you will get on solving this, it is 9 minus 6 minus 3 is equal to 0. So what we are saying, that P of 3 is equal to 0. It means 3 is a 0 of Px. Say 3 is a 0 of Px. Next, we have to calculate the value of P of minus 1. When you calculate P of minus 1, it is minus 1 square minus 2 into minus 1 minus 3. The answer you will get, it is 1. Then it is plus 2 minus 3 equal to 0. It means P of minus 1 is equal to 0. It means minus 1 is a 0 of Px. Now suppose if I calculate the value of P of say 2, or we are calculating the value of P of 1 in this case, then the answer you will get, it is 1 square minus 2 into 1 minus 3. So the answer we get, it is 1 minus 2 minus 3. So that is equal to minus 4, and it is not equal to 0. So we are saying that 1 is not a 0 of this polynomial. Now suppose I calculate the value of P of 0. I am calculating the value of P of 0. So P of 0 means in place of x we are writing 0. So it is x square minus 2 into 0 minus 3. The answer you will get, it is minus 3. So what we are saying is 0 is not a 0 of Px. This 0 is this real number 0, and this 0 we are saying, this is by the definition that is there. This is by the definition that is there. It is zeros of a polynomial. So you should not mix both these things. 0, the real number 0 we are talking about, it may be the 0 of the polynomial, or it may not be the 0 of a given polynomial. So definition of 0 of the polynomial means we are talking about a number which, when we calculate the value of that polynomial, it gives the answer equal to 0. Next we have is the graph of the linear polynomial. So we consider any linear polynomial, say it is fx is equal to ax plus b. It is linear polynomial, it means a is not equal to 0. So the graph of y is equal to ax plus b is a straight line. We are saying the polynomial that we have, it is fx is equal to ax plus b. In previous cases we were writing this thing as px is equal to ax plus b. Suppose we are writing it is equal to y. We have to draw the graph. So we will have x-axis and y-axis. So we are saying these are just the values of the polynomial at these points, at the points of x. So we are saying this is equal to y, and we are talking about this equation ax plus b. We are talking about this is ax plus b we are talking about equal to y, and we are saying this is a equation of the straight line. Why? Because from this equation, if we substitute the values of x over here, we will get different values of y, and we know that 2 points we can calculate from this equation. We are saying we can substitute some value, say x is equal to x1 and y x is equal to x2. Corresponding to this, we will get y is equal to y1, we will get y is equal to y2. When we substitute x is equal to x1, we get y is equal to y1. When we substitute x is equal to x2, we get y is equal to y2. What this thing means is, suppose the equation that is given to us is y is equal to 2x minus 5. So if we are substituting the value of x is equal to 1, what we will get? Y is equal to 2 into 1 minus 5 equal to minus 3. When we are substituting x is equal to 4, So we are getting 2 into 4 minus 5, that is equal to 3. So these are represented in this table. We are saying for x is equal to 1, y is equal to minus 3. For x is equal to 4, y is equal to 3. And if we plot these values on the graph, we are saying this is our x-axis, this is our y-axis. We have marked these points over here, 1, 2, 3, 4, then minus 1, minus 2, minus 3. On y-axis it is 1, 2, 3, 4. On negative side it is minus 1, minus 2, minus 3. Then next we have plotted the point 1 comma minus 3. So on x-axis we are saying this point is 1, and on y-axis this point is minus 3. Similarly, we have plotted this point 4 comma 3. This point is corresponding to 4 and 3. So this point is 4 comma 3. We are saying this is the point B. And when we join these 2 points, we obtain this line. We have obtained this line over here. This line we have obtained by joining the points A and B. And we are saying that this line is intersecting the x-axis at this point P. This line is intersecting this point, this x-axis at this point P, and this is basically the 0 of Px is equal to 2x minus 5. 0 of this means that this point 5 by 2, if we substitute over here, we are saying P of 5 by 2, that is 2 into 5 by 2 minus 5. The answer is 0. Why the answer is 0? Because we are saying this is the value of y. And by looking at this graph, what value of y is equal to 0 means? Value of y is equal to 0 means we are talking about all these points over here. At all these points on the x-axis, we are saying y is equal to 0. So we are saying at this point P, we are having the coordinates 5 by 2 comma 0. It means y is equal to 0 corresponding to the point 5 by 2. That is, for x is equal to 5 by 2, y is equal to 0. So 5 by 2, this point we are talking about, this is the 0 of Px. Next is we have to draw the graph of the polynomial x square minus 2x minus 8. So this is not a linear polynomial. This is a quadratic polynomial we are talking about. This polynomial we are saying this is a quadratic polynomial. Its degree is 2. So we are finding different points corresponding to different values of x. So suppose we have substituted x is equal to 0 in this equation. X is equal to 0 means we are talking about the value f of 0. So the answer we will get, it is 0 square minus 2 into 0 minus 8. So it is equal to minus 8. Next we have substituted f is equal to 1. So we will get, it is 1 square minus 2 into 1 minus 8. The answer we are getting, it is minus 9. For x is equal to 1, the answer we are getting, it is minus 9. Next, suppose we have calculated f of minus 1. So it is minus 1 square minus 2 into minus 1 minus 8, and on solving this you will get the answer is minus 5. So for x is equal to minus 1, the answer we have, it is minus 5. Similarly, if we calculate the values, or x is equal to 2, 3, 4, 5, 6 and minus 2, minus 3, minus 4, we have obtained these values corresponding to these values of, or y corresponding to these values of x. So if we plot these points, we are saying minus 4 comma 16. This is minus 4 comma 16. Next it is minus 3 comma 7. Minus 3 comma 7 means on y-axis it is minus 3, on x-axis it is minus 3, on y-axis it is 7. Next, suppose we are talking about the point minus, say I am talking about the point 1 comma minus 9. So 1 is the value on x-axis, minus 9 is the value on y-axis. We are saying 1 is the value on x-axis, this is the value on y-axis. 0 comma minus 8. 0 is the value on x-axis, this minus 8 is the value on y-axis. So we have plotted all these points over here. This is 6 comma 16, 5 comma 7, 4 comma 0, 3 comma minus 5, 2 comma minus 8, 1 comma minus 9. We have plotted all these points and we have joined all these points and we obtain the graph of this shape. We have obtained the graph of this shape, and this type of graph, this shape of this graph, it is called a parabola. This is not the exact definition of parabola that we are talking about, that you will study in your next classes. So these kind of shapes we are talking about. It may be like this, it may be like this, maybe like this, it may be like this. So all these are parabola. So what we are saying is that in case of the linear polynomials, we were having the straight lines, and in case of the quadratic polynomials, in particularly in this case, the shape that we have obtained, it is called the parabola. Now this, if you look at this shape, it is intersecting the x-axis at 2 points. One point is 4 comma 0 and second point is minus 2 comma 0. I'm talking about these 2 points. One is 4 comma 0 and second is minus 2 comma 0. So what it means, that for x is equal to 4, y is equal to 0, for x is equal to minus 2, y is equal to 0. So we are saying this graph is intersecting x-axis at 2 points. So we have 2 zeros of this polynomial. From this graph what we get is that it has 2 zeros. 2 zeros means that if we calculate the value of f of 4, the answer is 0. If we calculate the value of f of minus 2, the answer is 0. So we are saying 4 and minus 2, these are zeros of this polynomial. These two values, these are the zeros of this polynomial. This thing is explained in our next slide, that we are saying if let alpha be a real root of ax square plus bx plus c. This word real means that it is a real number. There are imaginary numbers also, but we are more interested in real numbers. Then we are saying if this is the real root of this, root means we are talking about basically zeros. We will see this definition in further. So we are saying that if alpha is the real root of this, it means alpha will satisfy this equation. So it is a alpha square plus b alpha plus c is equal to 0, and the point alpha comma 0 lies on the y is equal to ax square plus bx plus c. So what this thing means is that every real root of ax square plus bx plus c equal to 0 represents a point of intersection of the parabola with the x-axis. This thing we have already explained, that if these are the axes and this is the parabola, this is the parabola means this is the graph of the equation y is equal to fx. This is our x-axis. These are the points of intersections. We are saying if this is the point alpha, then alpha means this is the point of intersection of the parabola and the x-axis. This is the point of intersection of these two. And conversely, we can say if the parabola y is equal to ax square plus bx plus c intersect the x-axis at the point alpha comma 0, then alpha comma 0 satisfies this equation. Alpha comma 0 satisfies this equation. It means this value is equal to 0. So the intersection of the parabola this with the x-axis gives all the real roots of ax square plus bx plus c is equal to 0. So what we are saying is that this parabola is given, the intersection of all these points, this is say alpha 1, this is alpha 2, so these are the, we are saying these are the roots of or zeros of the polynomial, or we are saying these are the roots of the given quadratic polynomial. Next is this quadratic polynomial is given to us and we have to draw the graph of this polynomial. So it is fx is equal to 3 minus 2x minus x square. So again we have listed some points over here that corresponding to 0. When you will substitute 0 over here, you will get the value of y is 3. For x is equal to 1, the value of y is 0. For x is equal to 2, the value of y is minus 5. For x is equal to minus 1, the value of y is 4. For x is equal to minus 2, the value of y is 3. So likewise we have for corresponding to the points minus 5, minus 4, minus 3, minus 2 and this 3, 4, we have calculated the values of this polynomial. We have calculated the values of this polynomial, and when we draw these points on the graph, we are saying this is the x-axis, this is the y-axis, and we have plotted all these points over here. We have plotted this point 4 comma minus 21, 3 comma minus 12, 2 comma minus 5. Likewise we have plotted all these points over here and we obtain the shape like this. We have obtained this shape over here, this shape we are talking about. When we join these points, we obtain this kind of shape. So this is the required parabola, and we can see from this figure that it is intersecting with x-axis at these 2 points. One is minus 3 comma 0 and second is 1 comma 0. It means the zeros or roots of this polynomial, they are 1 and minus 3. This is x is equal to 1, x is equal to minus 3. For x is equal to 1, y is equal to 0. For x is equal to minus 3, y is equal to 0. So it means if this graph is given to us, from this graph we can tell that the point of intersection of this parabola with this x-axis, these 2 points, these represents the roots of this polynomial or fx, this quadratic polynomial fx. Next is graph of a cubic polynomial. So graph of cubic polynomial does not have a fixed standard shape, just like the previous 2 cases, that the linear polynomial is a straight line. The quadratic polynomial, if it has the real roots, then we are saying that the parabola will be there and it will intersect the x-axis. So basically the shape of the quadratic polynomial, it is of the parabolic shape. Now we are talking about the cubic polynomial. So there is no fixed name for these polynomials, or we are saying there is no fixed shape that the graph of these polynomials have. But one thing is important to note over here, that cubic polynomial graph will always cross x-axis at least once and at most thrice. We are saying when we have drawn the linear polynomial, it is a straight line, so it will intersect the x-axis at most one time. At most one time means that the graph may be like this, that it is not intersecting the x-axis. If we are talking about the quadratic polynomial, the graph may be like this, the graph may be like this. So there might be the case that it is not intersecting the x-axis. It is not intersecting the x-axis. So the maximum number of times it can intersect is, if suppose we are saying it is like this, then the maximum number of times it can intersect it is 2. So the maximum roots it can have it is 2. Now in case of the cubic polynomials, we are saying it will intersect or it will cross x-axis at least once. It means it will always have at least one real root, and at most thrice means it can have at most 3 real roots. So we try to plot the polynomial. Suppose the polynomial that is given to us, it is fx is equal to x cube minus 4x. Similarly, we list the values over here corresponding to 0. X is equal to 0, we have y is equal to 0. For x is equal to 1, you will get the value of y is minus 3. Value of y means we are writing this equation as y is equal to x cube minus 4x, or we are saying fx is equal to this. So the value of y at, say, x is equal to minus 2 if we are calculating, so it is minus 2 cube minus 4 into minus 2, so it is minus 8 plus 8 equal to 0. So what we get is that corresponding to x is equal to minus 2, we have y is equal to 0. So if we plot all these points on this graph, it is minus 3 15, minus 2 0, minus 1 3, then next it is 0 0, 1 minus 3 2 0, 3 15. So, and we join all these points like this. So we have obtained the graph in this form, and this is the graph for the cubic polynomial. This is important to note over here that we have just joined the graph with free hand. These are not the straight lines. These are, while joining 2 0 and 3.315, we are not using straight line. We are just joining these 2 points with by hand, free hand. So if we look at this graph over here, we see that this at minus 2 0, 0 0 and 2 comma 0, these are the 3 points where it is intersecting the x-axis. This is our x-axis, and this graph is intersecting the x-axis at 3 points, and these 3 points are minus 2 0, second is 0 comma 0, and next is 2 comma 0. So what we see from this is, for this cubic polynomials, the roots are minus 2, 0 and 2. These are the 3 real roots. So one thing that I am again repeating, the important thing to note over here is that cubic polynomials, they have at least one real root. One real root is always there, and they can at most have 3 real roots. That this line can intersect, this curve can intersect the x-axis at most at 3 points. Next is, for the graph of the polynomial x cube minus 4x, the following observations are there. We have noted some observations. The polynomial, if we are talking about x cube minus 4x, we can write it is x into x square minus 4. So it is x into x minus 2 into x plus 2. This 4 you can write it is 2 square, so it becomes x square minus 2 square. So it is a square minus b square. So this polynomial can be factored into 3 terms which are linear. So we are saying that the curve y is equal to fx also cuts x-axis at 3 distinct points. And second thing that we have noted is, if we equate these 3 points equal to 0, we get x is equal to 0, or x is equal to minus 2, or x is equal to 2, and these are 3. Why we are getting this? We are getting x is equal to 0, or it is x is equal to x minus 2 is equal to 0, and next it is x plus 2 is equal to 0. When you will solve this, you will get x is equal to 2. When you will solve this, you will get x is equal to minus 2. So these are the 3. We are saying these are the 3. 0, 2 and minus 2 are the 3 zeros of fx. These are basically the 3 zeros of x that we are obtaining as the points where y is equal to fx cuts x axis. So these were some basic facts about the graphs of the polynomials. Next is relation between the zeros and the coefficients of a quadratic polynomial. So suppose we are given a quadratic polynomial. It is px is equal to ax square plus bx plus c. It is quadratic polynomial. It means its a is not equal to 0, and we are saying suppose alpha and beta, these are the zeros of this polynomial px. If these are the zeros of this polynomial px, it means x minus alpha and x minus beta, these are factors of px. So what we get is that px equal to ax square plus bx plus c, that is equal to k times x minus alpha into x minus beta. Now if we solve these values, we get it is k times x square alpha plus beta x plus alpha beta. So this is kx square minus k into alpha plus beta times x plus k times alpha beta. Now if we compare these coefficients on both these sides, we are talking about this is the term of x square, this is the term of x square, this is term of x, this is term of x on this side, this is constant term and this is the constant term. So what we get is that a is equal to k. Next we have is b is equal to minus k times alpha plus beta, and next third we have it is c is equal to k times alpha into beta. So if we substitute the value of k as a in these equations, what we get is that minus b is equal to minus b over a is equal to alpha plus beta. We have substituted k is equal to a, we are substituting this value over here. So what we get is alpha c over a is equal to alpha into beta. This thing is mentioned over here that alpha plus beta is equal to minus b over a, and alpha into beta is equal to c over a. So what alpha plus beta means? Alpha and beta, these are the zeros of the quadratic polynomials. So it means this is sum of roots or sum of zeros. You are saying this is product of zeros. When we are talking about polynomial, we are talking about zeros. When we are talking about polynomial equations, we are talking about the roots. So we have two results over here. One is that sum of roots is equal to coefficient of minus sign is there. This is important, that this minus sign is there. It is coefficient of x over coefficient of x square, and product of zeros is constant term over coefficient of x square. So we are saying if alpha and beta are the zeros of polynomial this, then alpha plus beta, these are the same expressions that we are again talking about. This result we are saying, this we have already mentioned, that if alpha and beta are the zero of the polynomial px equal to x square plus bx plus c and a is not equal to 0, then alpha plus beta is equal to minus b by a, and alpha into beta is equal to c by a. Now the second thing we are talking about is if a quadratic polynomial whose roots are alpha and beta, then that polynomial will be of the form this, that px is equal to x square minus alpha plus beta x plus alpha into beta. Then the polynomial will be of this form. So based upon this, we solve certain problems. So our first example is find the zeros of the polynomial 2x square plus 5x minus 12. This is the polynomial given to us, and verify the relation between its zeros and coefficients. So to find the zeros of this polynomial, we are saying it is fx is equal to 2x square plus 5x minus 12. We are splitting the middle term over here. Splitting the middle term means that we want to split this term in such a way so that if I am talking about two numbers a and b, then a plus b should be equal to 5 and a into b should be equal to 2 into minus 12. So we are splitting the middle term and we get it is 2x square plus 8x minus 3x minus 12. The splitting the middle term we have already done in our class 9. So you can see that video to see how we are splitting these terms over here. So from the first two terms we take 2x common, so it is x plus 4. From this we are taking minus 3 common, so it is x plus 4. So we are left with this 2x minus 3 into x plus 4. Now we have to find the zeros of this polynomial. It means we are going to equate it equal to 0. So we get 2x minus 3 is equal to 0 or x minus 4 is equal to 0. So x is equal to 3 by 2 or x is equal to 4. This is x plus 4 is there. So the answer we will get it is x is equal to minus 4. So we are saying the zeros of fx are minus 4 and 3 by 2. Now if we use the formula, the previous formula that we are talking about, so sum of the zeros, suppose we are saying this is alpha and this is beta. So alpha plus beta, that is equal to minus 4 plus 3 by 2, that is equal to minus 5 by 2, and that is equal to, this is minus 5 by 2. So this is 5 over here and 2 over here. So we are saying this is the value minus coefficient of x over coefficient of x square. And when we are talking about alpha into beta, that value is equal to minus 4 into 3 by 2. So the answer is minus 12 by 2. Basically it is 6. We are writing it is 12 by 2 because this minus 12 is C and this 2 is A. So we are saying this is equal to C by A. That is equal to constant term over coefficient of x square. So we see that our formula is verified. This is our second part, verify the relationship between the zeros and coefficients. So this relationship is verified. Now next question, again we have to find the zeros of this polynomial and we have to verify the relationship between the zeros and the coefficients. So to find the zeros of the polynomial, we are writing it in the standard form. It is 6x square minus 7x minus 3. Now what we have to do is, this term is minus 7 over here and product of these two terms, it is 18, and we can see that 9 into 2 is 18 and 9 minus 2 will be 7. So we can write this as 6x square minus 9x plus 2x minus 3. So it is 3x is common, so we are left with this x minus 2x minus 3 plus 2x minus 3. It is 1 into 2x minus 3 over here. You must write this one, otherwise you will commit the mistake in the next step. So when you will take 2x minus 3 common, what we are left from this is 3x, and from the next one we are left with this 1. And when we are finding the zeros of this polynomial, finding the zeros means we are writing fx is equal to 0. It means we are equating this term equal to 0. So we get 2x minus 3 is equal to 0, or 3x plus 1 is equal to 0. This gives us x is equal to 3 by 2, or x is equal to minus 1 by 3. So suppose these are the values of alpha and beta. So what is alpha plus beta and alpha into beta? So alpha plus beta is 3 by 2 plus minus 1 by 3. It is 7 by 6. Alpha into beta is 3 by 2 into minus 1 by 3. That is minus 3 by 6. So what is 7 by 6 over here? We are not looking at this polynomial now. We are looking at this polynomial over here. This is the standard form we are talking about. So this is the value of A, this is B, this is C. B means we have value of A is equal to 6, B is equal to minus 7, C is equal to minus 3. These are the three values that we have. So what we get from this is equal to minus B by A, and this is equal to C by A. We are talking about this value is minus B by A. B is minus 7, A is 6. Next it is C by A. C by A means C is minus 3, A is 6. So we are saying we have verified the relation between the zeros and the coefficients. Next, the polynomial fx is equal to x square minus 2 is given to us, and we have to find the zeros of this polynomial and verify the relation between zeros and the coefficients. So x square minus 2, we are saying suppose it is equal to 0. So we get it is x square minus root 2 square equal to 0. So it is x minus root 2 into x plus square root 2 equal to 0. So we get x minus root 2 is equal to 0, or x plus square root 2 is equal to 0. So we get x is equal to square root 2, or x is equal to minus square root 2. So sum of the roots will become, suppose this is alpha, this is beta. So alpha plus beta, sum of the roots, that is equal to root 2 plus minus root 2 equal to 0. And product of the roots, alpha into beta is equal to root 2 into minus root 2, that is equal to minus 2. Now if we look at this polynomial over here, we have the value of A is equal to 1, B is equal to 0, because there is no term over here. Over here we are saying it is 0x plus this. And the value of C that we have, it is minus 2. So we are saying this is equal to minus B by A. Minus B by A means the value of minus B means it is 0. The value of A we have, it is 1. And next we are saying this is equal to C by A. The value of C that we have, it is minus 2, and the value of A that we have, it is 1. So we are saying that we have verified the relation between the zeros and the coefficient. Next is obtain the zeros of the quadratic polynomial this. So the polynomial that is given to us, it is root 3x square minus 8x plus 4 root 3. So if we look at the product of these two values, the product of these two values we are talking about, so it is root 3 into 4 root 3, that is equal to 4 into 3 is equal to 12. So it means we have to split this term 8x such that the product is 12. So it is 6 and 2. So we can write it is root 3x square, then it is minus 6x minus 2x plus 4 root 3. Now what we have to do is suppose I am taking root 3 common from the first two terms. Suppose I am taking square root 3 common from first two terms. It means what I am going to do, I am going to write root 3 over root 3 over here. So if I will take square root 3 common from this term and x common, so in the first term I am left with x minus, it is root 3 I have already taken common, so I am left with is 6 over root 3. Then it is minus, I will take 2 common, and it is x minus 2 root 3. If we look at this value, it is 6 over square root 3, and I rationalize this value. It is square root 3 over square root 3. Square root 3 over square root 3 means it is root 3. This is 3. Square root 3 over square root 3 means this is 3. And this 3 and 6 gets cancelled, and I am left with this 2 root 3. So this becomes root 3x into x minus 2 root 3 minus 2 into x minus 2 root 3. So it is square root 3x minus 2 into x minus 2 root 3. And when we have to find the zeros of this polynomial, we will equate it equal to 0. We will get root 3x minus 2 is equal to 0, or x minus 2 root 3 is equal to 0. This gives us x is equal to 2 by square root 3, or x is equal to 2 root 3. So these are the two zeros of this polynomial. Suppose we are saying this value is alpha and this value is beta. So alpha plus beta, that is equal to 2 by square root 3 plus 2 root 3. The answer is 8 by square root 3. When you will take the LCM over here for these two terms, it will become 2 into root 3 into root 3. Root 3 into root 3 means it is 2 into 3, that is equal to 6, and the 6 plus 2 you will get it is 8. Next we are saying it is alpha into beta, so it is 2 by root 3 into 2 into root 3, so it is equal to 4. Now come to this equation again. We are saying the value of a we have it is root 3, value of b we have it is minus 8, and value of c we have it is 4 root 3. So when we are talking about the sum of the roots, it is minus b by a. What is value of b? It is minus 8. What is value of a? It is square root 3. Similarly, in this case, we have it is c by a. So what is the value of c over here? The value of c is 4 root 3, and value of a is square root 3. So we have verified the relation between the zeros and the coefficients of this polynomial. Next we are saying find a quadratic polynomial, the sum and product of whose root zeros are minus 5 and 6. So suppose alpha and beta be the zeros of the polynomial, then alpha plus beta is minus 5 and alpha into beta is 6. These two things are given to us, and we know that if the sum and product of the polynomials are given, then the polynomial will be of the form x square minus alpha plus beta x plus alpha into beta. These are the values given to us, that alpha plus beta is minus 5 and alpha into beta is 6. We substitute these values over here, minus 5 and 6 over here, and we get the answer is x square plus 5x plus 6. So this is the required polynomial. Next is, if the product of the zeros of the polynomial this is 4, this polynomial is given to us and it is given that the product of its zeros is 4, we have to find the value of a, and we know that the product of this polynomial, the product of zeros will be minus 6 by a, that is c by a, and its value is given to be 4. So it means the value of a will be minus 6 by 4, that is equal to minus 3 by 2. This is the value of a that is required. Now next is find the quadratic polynomial, the sum of whose zeros is root 2 and their product is minus 12. So suppose we are saying alpha and beta, these are the zeros of the required polynomial. So alpha plus beta is root 2 and alpha into beta is minus 12. If the sum and product are given, then the formula to find the polynomial is x square minus alpha plus beta x plus alpha into beta. This is the required polynomial. We substitute these values over here, that alpha plus beta is root 2 and alpha into beta is minus 12. When we substitute these values, we get this is the required polynomial. Now we have to find the zeros of this polynomial. So to find the zeros, it means we have to factorize this polynomial first. So if we look at this polynomial, it is x square minus root 2x minus 12. So what we want is that the sum should be minus root 2 and product should be minus 12. We have to find two numbers a and b in such a way, and those two numbers, if sum is square root 2, suppose I am talking about two numbers are there a and b, I want to write it in the form x square minus some ax plus bx, then it is plus minus a into b. So we are saying that the value of minus a plus b should be equal to root 2 and minus a into b should be equal to 12. If we look at this value over here, minus a plus b should be equal to root 2, it means both these a and b, these should be of some form, say a1 root 2 and b1 root 2. These should be something like this. So if we substitute this value in this, we are saying it is a1 root 2 into b1 root 2. So answer is a1 b1 into 2, that should be equal to 12. So a1 into b1 should be equal to 6. We are saying a1 b1 should be equal to 6 and minus a plus b should be equal to 1. We are saying these root 2 we have already adjusted over here, so we need some values like this, and we know that these values will be 2 and 3. So what we are going to do is we are going to write this in the form x square minus 3 root 2x plus 2 root 2x. We are saying a1 b1, we are talking about these values over here, these are 2 and 3, a1 root 2 and b1 root 2, these should be the numbers. So we are saying a1 root 2 means we are talking about it is 3 root 2 and this is 2 root 2. So this value we obtain and it is minus 12 over here. We look at this term, we can take x common from this, so it is x into x minus 3 root 2. From the next term, we can take 2 root 2 common. Why we are taking 2 root 2 common? Because the term we require over here, it should be x only. The term we require over here, it should be this x only. So we are taking 2 root 2 common. So what we are left over here, it is x minus 12 over 2 root 2. Look at this term over here. It is 12 over 2 root 2. We rationalize this, it is root 2 over root 2. This term will become 4. These two will get cancelled and we are left with this 3 root 2. So what we get is x minus 3 root 2 plus 2 root 2 into x minus 3 root 2. So this will give us that x minus 3 root 2 into x plus 2 root 2 equal to 0, and from this we will get the value of x is 3 root 2 or x is minus 2 root 2, and these are the required roots or zeros of this polynomial. When we are using this word root in this case, when we are saying this root, it means we are talking about square root. So there are different terms over here. When we are talking about zeros of the polynomial, it means something else. When we are talking about the number 0, it is something else. When we are talking about the square root, it is something else. When we are talking about the root of the polynomial, it is something else. Next is if 1 0 of the polynomial, this polynomial is given to us, and it is given that 1 0 of this polynomial is reciprocal of the other, we have to find the value of a. So we are saying, suppose one of the zeros of this polynomial is alpha, then the other 0 is 1 over alpha. It is reciprocal. So it means product of both these, alpha into 1 by alpha, that is equal to 1, that is equal to c by a. C by a means constant term over coefficient of x square. So it is constant term over here. This 6a is constant term and this is the coefficient of x square. So we get it is 6a over a square plus 9. So we get 6a over a square plus 9 equal to 1. It means a square plus 9 is equal to 6a. It means a square minus 6a plus 9 is equal to 0. This is a minus 3 square equal to 0. It means a is equal to minus 3 comma minus 3. These kind of roots you will write minus 3 comma minus 3, because when you will write this, it is a minus 3 into a minus 3 is equal to 0. So you will get a is equal to minus 3 comma minus 3 means these kind of roots, these are called repeated roots. These are called repeated roots. So we are saying it is a quadratic polynomial. It has two real roots, and both these roots, these are minus 3 and minus 3. So if we look at the graph for such kind of quadratic polynomials, it may be something like, it is something like this, that the parabola that we have, that is just touching this x-axis. So it seems like that it is intersecting only at one point. So we are saying that point is basically this we are talking about. This case represent it as repeated roots. It has two roots, and these two roots, these are repeated roots. Next is find a quadratic polynomial whose zeros are 1 and minus 3. Verify the relation between the coefficients and zeros of the polynomial. So we have to find the quadratic polynomial. So it is given that alpha is equal to 1, beta is equal to minus 3. So alpha plus beta, sum of the roots will be minus 2. Product of the roots will be minus 3. We know the formula for the required polynomial will be x square minus alpha plus beta x plus alpha beta. We substitute these values over here, and we get the answer is x square plus 2x minus 3. Now if we calculate the sum of zeros, that will be minus 2 by 1, and product of zeros, that will be minus 3 by 1. So it will verify the relation between the coefficients and the zeros of the polynomial. Next are some general formulas that we have. We are saying if alpha and beta are the roots of equation ax square plus bx plus c is equal to 0, then we can find the value of the following expressions as follows. So this is a quadratic polynomial that is given to us, and we are saying alpha and beta, these are the roots. Suppose we have to find the value of alpha square plus beta square. So what we are going to do is, the values that we know is alpha plus beta, that is equal to minus b by a, and alpha into beta, that is equal to c by a. We want to calculate the value of alpha square plus beta square. So what we are going to do is, we are going to use the formula alpha plus beta whole square, that is equal to alpha square plus beta square plus 2 alpha beta. So this gives us the value of alpha square plus beta square is alpha plus beta whole square minus 2 alpha beta. Suppose I have to explain this with an example. I am saying a polynomial is given to us. Say that polynomial is x square minus 2x plus 1 equal to 0. Now from this polynomial, one thing is clear, that alpha plus beta is equal to 2 and alpha into beta is equal to 1. This is minus b by a and this is c by a. We want to calculate the value of all these terms. So what we are going to do is, one method is that you will calculate the root, you will find the value of alpha and beta and you will solve it, but it is not always possible to find the value of alpha and beta if the equation is somewhat complex. So in place of doing this, if we have to calculate the value of alpha square plus beta square, we will use this formula and we will get alpha square plus beta square. So alpha plus beta is 2 square minus 2 into 1. So answer is 4 minus 2 is equal to 2. If we have to calculate the value of alpha cube plus beta cube, so the formula we are going to use, it is alpha plus beta whole cube, that is equal to alpha cube plus beta cube plus 3 times alpha beta into alpha plus beta. So this gives us that alpha cube plus beta cube is alpha plus beta whole cube minus 3 times alpha beta into alpha plus beta. You will substitute these values over here. Alpha plus beta we know, alpha into beta is 1, so you will get the answer. Next, if we have to calculate the value of alpha raised to power 4 plus beta raised to power 4, what formula we are going to use? It is alpha square plus beta square whole square. It is equal to alpha raised to power 4 beta raised to power 4 2 times alpha square beta square. So we get alpha raised to power 4 plus beta raised to power 4, that is equal to alpha square plus beta square whole square minus 2 times alpha square beta square. This value alpha square plus beta square we already know from here. So the answer we will get, it is alpha plus beta whole square minus 2 alpha beta square minus 2 alpha beta whole square. So if we substitute these values over here, the answer we will get, it is 2 square minus 2 times 1 and whole square minus 2 into alpha into beta is 1 square. When you will solve this, you will get the required answer. So these are the formulas that we can use. Then alpha minus beta whole square, if you have to calculate, you can use this formula. If alpha raised to power 4 plus beta raised to power 4 you want to calculate, you can use this kind of relation. So these are some basic identities that are given to you. These are basically the identities that are given to you to calculate these values. Next is, if alpha and beta roots of this equation form an equation whose roots are alpha plus 1 by beta, beta plus 1 by alpha. So we are saying the roots of the given equation, they are in this form. So sum of the roots, in this case it will be alpha plus 1 by beta plus beta plus 1 by alpha. So it is alpha plus beta, alpha beta into alpha plus beta. Now what is alpha plus beta? Alpha and beta, these are the roots of this equation. So it is minus b by a minus b by a over c by a. The answer you will get, it is minus b into a plus c by ac. These are the sum of the roots. If we are talking about the product of the roots, the product of the roots is, we are saying it is, this is the product of the two roots. When you multiply these terms, you will get the answer is c plus a whole square over ac. So what we have is the new equation that we have to find. The sum of the roots is this and the product of the roots is this. So the required equation, we know it is x square minus sum of the roots plus product of the roots. So we have substituted the value of sum of the roots and we have substituted the value of product of the roots. So this is the required equation. Similarly, in the second case, we have calculated the sum of the roots. We obtain this form and we obtain this answer. These calculations you can try at your own. Product of the roots we have calculated. These are the product of the roots of the new equation. The answer we will get, it is a over c. We will substitute this value in this formula. We'll substitute these values in this formula and we will get the equation in this form. This is the new equation. So we are saying this is the original equation that we have. These are the roots of this equation. We have to form new equation. These are the new roots we are talking about. These are sum and product of new roots. From this we have calculated these new equations. So these calculations you can see at your own, that how we are going to calculate these values. Next is the relation between the zeros and coefficients of a cubic polynomial. So suppose we are saying a cubic polynomial, yes, px is equal to ax cube plus bx plus c plus d is equal, this is given, is not equal to 0, it means it is cubic polynomial, and it is given that alpha, beta and gamma, these are the zeros of the cubic polynomial. So it means that this factor of the cubic polynomial, they are x minus alpha, x minus beta, x minus gamma. These are the factors of the polynomial px. So again, as we have done in the previous case, if we multiply these three terms and we equate the coefficients on both sides, we are saying that the polynomial we have, it is a x cube plus bx square plus cx plus d. This side we are saying it is k times x minus alpha, x minus beta, x minus gamma. We multiply these terms and we obtain, this is the cubic polynomial now we have. So the coefficient of x cube, it is a and k. So we are saying k is equal to a. Next, coefficient of x square is k alpha plus beta plus gamma, and over here the coefficient is b. Similarly, this is the coefficient of x and this is the constant term we are talking about. So on solving these values, we will obtain the formula in this form, that the sum of the three roots, it is minus b by a. This is sum of the roots taking 2 at a time. We say it is c by a. By solving this you will get this formula, and the third value you will get, it is product of the three roots, it is minus d by a. This is the product of the three roots that we will have. So these are the formulas for the sum of the roots, sum of two roots taken, sum of the roots taken 2 at a time, and this is product of the three roots, and these are the required formulas for the cubic polynomials. Now next is verify that question we have is that 3 minus 1 minus 1 by 3 are the zeros of the polynomial this, and verify the relation between its zeros and coefficient. So first of all, we have to prove that these three values, these are the zeros of this polynomial. So to prove that these are the zeros, we have to prove that p of 3, we have to find the value of p of 3, we have to find the value of p of minus 1, we have to find the value of p of minus 1 by 3. Suppose I am talking about p of minus 1 by 3, it means it is 3 into minus 1 by 3 cube minus 5 into minus 1 by 3 square minus 11 into minus 1 by 3, then minus 3. When you will solve these values, you will get it is 3 into minus 1 by 27, 5 into 1 by 9 plus 11 by 3 minus 3. On solving this, you will get the final answer is 0. Similarly, when you will calculate p of minus 1, you will get the answer is 0. And when you will calculate p of 3, you will get the answer is 0. These calculations, these are shown over here. These calculations are shown over here. And you will get that the final answer in all these three cases, it is 0. So what we get is that 3 minus 1 and minus 1 by 3, these are the zeros of these polynomials. So if we calculate the sum of the roots or sum of the zeros, so it is 3 plus minus 1 plus minus 1 by 3. The answer we will get it is 5 by 3, that is equal to minus coefficient of x square over coefficient of x cube. Next is the sum of the coefficients taken roots taken 2 at a time. So it is 3 into minus 1 plus 3 into minus 1 by 3 plus minus 1 into minus 1 by 3. When you will calculate these values, you will get the final answer is minus 11 by 3. And this value is just the coefficient of x. Coefficient of x means we are talking about it is 11 and over coefficient of x cube, and the coefficient of x cube it is 3. So this is the answer that we have obtained over here, that the coefficient of we have it is minus 11. This value you can see from this place, this is minus 11, and the coefficient of x cube that we have it is 3. Similarly, in the third case we are saying it is product of roots. So product of root is 3 into minus 1 into minus 1 by 3. So the answer we have it is 1, and that is equal to minus sign constant term is minus 3 over coefficient of x cube it is 3. So when you will solve this value, you will get the answer is 1. So these three things we have verified over here, that alpha plus beta plus gamma, that is equal to this value. Alpha beta plus beta gamma plus gamma alpha, that is equal to this. And alpha into beta into gamma is minus of constant term over coefficient of x cube. So we have verified the relation between the zeros and the coefficients. Now next we have find a cubic polynomial with the sum of its zeros, sum of the product of its zeros taken 2 at a time, and product of its zeros as 2, minus 7 and minus 40. So what is given over here is sum of the alpha, beta and gamma. Sum of the zeros is given to be 2. Sum of the zeros taken 2 at a time, alpha beta plus beta gamma plus gamma alpha, that is equal to minus 7, and product is given to be alpha beta gamma is minus 14. Now suppose we are saying the polynomial that we have, it is of the form, the required polynomial we are saying it is x cube plus bx square plus cx plus d is equal to 0. This is the polynomial we are talking about. Now if we look at this polynomial and suppose the roots of this polynomial, they are alpha, beta and gamma. So what we get is that alpha plus beta plus gamma, that is equal to minus b. Then alpha beta plus beta gamma plus gamma alpha, that is equal to c, because the constant term we are saying over here, this coefficient of x square we have taken 1, so it is b over 1, this is c over 1, and the next term we have, it is alpha into beta into gamma is equal to minus d over 1. So what we get is the value of b is this, c is this, and d is minus d is this. If we substitute these values over here, we get it is x cube minus alpha plus beta plus gamma times x square plus alpha beta plus beta gamma plus gamma alpha times x, and last we have it is minus alpha beta gamma, that is equal to 0. If you write it equal to 0, it will become a polynomial equation. Otherwise we are just talking about the polynomial, so you can leave this term from here. So you will get the answer is this. This is the formula that we have. So we are saying that the polynomial px will be of this form. Now we have value of alpha plus beta plus gamma is equal to 2. Value of alpha beta plus beta gamma plus gamma alpha, that is equal to minus 7, and the value of alpha beta gamma we have, it is minus 14. So this is the required cubic polynomial in this case. Next is, if the zeros of the polynomial, this polynomial is given to us, and we are saying its zeros are a minus b, a, and a plus b, and we have to find a and b. So what we can see from this is, suppose these are the values we are saying, this is alpha, this is beta, this is gamma. So what we get is that alpha plus beta plus gamma, that is equal to a minus b plus a plus b. This gets cancelled and it is minus 3 times a, and we know that its value will be equal to 3. Why it is equal to 3? It is coefficient minus of coefficient of x square over coefficient of x cube, so it is 3 over here. So this gives us that the value of a is 1. This is not minus, this is 3a we have equal to 3, so the value of a that we will have, it is equal to 1. Next, if we calculate alpha beta plus beta gamma plus gamma alpha, that is equal to 1. The coefficient over here, it is 1, coefficient over here, it is 1. So we get, if we calculate these values, we have substituted these values over here, we are saying this complete value is equal to 1. The value of a we have calculated it is 1. So on solving this, you will get the value of b is equal to plus minus square root 2. On solving this value, you will get the answer that b is equal to plus minus square root 2. So these are the values of a and b that are required. Next is, find a cubic polynomial whose zeros are 3, 1 by 2 and minus 1. So formula we have already seen in our previous question, that what we need to find is the required polynomial will be x cube minus alpha plus beta plus gamma times x square. This is sum of the roots. Sum of the roots taken 2 at a time, and sum product of the roots. So these are the values of alpha is 3, beta is 1 by 2 and gamma is minus 1. So sum of the roots is 5 by 2. Sum of the roots taken 2 at a time, it is minus 2, and product of the roots, it is minus 3 by 2. So if you substitute these values in this formula, you will get this is our final answer. This is our final answer. This is the required polynomial.